Hi, my name is Matthew Hines. I'm the Chief Product Officer at RDX Works. I'm here to talk to you today about NFTs. And where I want to start is just talking about what are NFTs exactly. And then I'm going to get into a little bit more about the future NFTs and why we think they're so interesting and exciting. So let's start with the basics. First of all, what is an NFT? It's a non-fungible token. That's what NFT stands for. Now, that's kind of a complicated term that doesn't tell you a whole lot, but people seem to be really excited about them. So why is it that the world seems to care so much about non-fungible tokens? Well, the reason why is this kind of stuff hits the news pretty regularly these days. An NFT sold for $69 million. NFTs have been selling for huge amounts of money. They've been issued by Nike and other companies. There's a lot of excitement around NFTs and a lot of money around NFTs. But to understand what that craziness is actually about, we kind of have to go back a little bit because it's really pretty difficult to understand unless you've been really in it since the beginning. Looking from the outside, you can understand how someone looks at NFTs and goes, this is insanity. There's nothing here, and yet there's all this money. So let's take a little step back and talk about the history of NFTs and how we got to where we are today. So the story begins with Bitcoin in 2009. And Bitcoin is really kind of a simple technology in the end. Now it's become, it's something that everyone's aware of right now, but in the end, it really is just this one thing. It is a network that supports this one application. And that network, you can kind of think of as a distributed database. Blockchain technology, which Bitcoin was the beginning of, is basically a way of a bunch of computers on the open internet to create a shared database that we can all trust, where there's no company that's sort of calling the shots on what goes into that database and what comes out of it. So imagine if you have that kind of database, and I'm not going to go into how all that works. If you have that, you can do stuff with that. And Bitcoin as the network isn't just a database, it's also this application running on top of the database that basically is Bitcoin, the token, the thing that you're actually thinking about when you think about buying a Bitcoin or trading Bitcoin. It's about what you're basically doing is interacting with this application running on this network. So it really just does that one thing, the Bitcoin network. You can run these rules that creates token sort of behavior. It enforces the fact that there's only so much Bitcoin at a given point in time. And if I have some Bitcoin, it means that someone else can't have that same Bitcoin. No one can just decide to create more Bitcoin or to destroy Bitcoin that exists. It basically starts acting like digital cash, which was the point of Bitcoin. Now, you can argue the value of that digital cash, and then this is a whole other point, but just in terms of the technology, you have cash-like behavior. You have the fact that you have this thing that you can hold, you can trust that it's going to continue to exist, and you can transact it around between people. That's basically what Bitcoin is. So if we go from there, if we fast forward a few years to 2015, we get to Ethereum. And maybe less of you have heard of Ethereum, I'm sure some of you have, but Ethereum introduced the concept of smart contracts to blockchain. Basically what that did is it made it much more flexible. The bottom part of it, the network part of it, the distributed ledger part is actually quite similar to Bitcoin, but it added more functionality to that application layer. Now, rather than just running this one simple application that just manages the supply of Bitcoins, now you had the ability of anybody coming to the network and deploying what are called smart contracts. And a smart contract is basically just a piece of code that runs on that network. The network runs it for you. It's kind of like a big mainframe now. Now, rather than just having this network that runs Bitcoin, now it's this open computing platform where anybody can deploy a piece of code and the network will run that piece of code for you. And all those little pieces of code, smart contracts, can talk to each other. That's all a smart contract is. I think it's actually kind of a weird term, smart contract, because it suggests something that I don't think it really is. It's really just a program running on a distributed network. So that's what Ethereum is about. And that was a revolutionary change. Now you had much more flexibility. Now you can imagine running all sorts of applications in this sort of open environment, and people started exploring interesting ideas. So, all right. We're trying to get back to NFTs, right? So let's get back to tokens. How do tokens fit into this big picture? Well, a token, a simple token, a token along the lines of Bitcoin or other tokens that you might have heard of, cryptocurrencies would be another way of looking at it. Tokens would be built in this kind of way in that environment. You would have these smart contracts, and each token is represented by its own smart contract. So maybe you've got a token called USDC, or you've got one called SHIB or WBTC or whatever it is. And each one of those smart contracts maintains its own little internal list. You'd have a list of, you'd say, I am represented by a particular address on that network, and I can have entries of that address in multiple of these token smart contracts. So let's say in the USDC smart contract, my entry has a 50 associated with it for my balance. What that means is I own 50 of the USDC token, and so that smart contract would have to implement logic that says, well, if I want to send tokens to someone, it needs to reduce my balance and increase the balance of somebody else. So you get sort of token-like behavior. So you can create tokens on Ethereum, and you can do whatever you like with them. You can build logic around this kind of stuff. And you, again, rather than just having a single Ethereum token, you now have all of these tokens that anybody can create. It's pretty simple, but that alone, a couple of years later, led to what was called the ICO craze. So ICOs were called initial coin offerings. Basically, once people realized that, wow, anybody can create a token and put it on with these decentralized network, people started thinking of things of what those coins could represent, and they started selling them to people. They said, well, I'm going to create a supply of these tokens. They represent something, and you can buy some of those tokens for me in this initial offering of that coin. And so you got a lot of more headlines that came out around 2017 that said, a startup just raised $4 billion without a live product. They basically put a coin out there. They made promises about what that coin was going to represent once the system was finished, and people raised a huge amount of money. So this also was a little bit crazy. This was sort of the NFT craze of a few years ago. Okay. This is all still talking about tokens though, so we still need to come back to non-fungible tokens here. These are not non-fungible tokens. These are just plain old tokens. So what's a non-fungible token? Well, let's put it in the same terms. How would you implement that in this smart contract model? Well, as it turns out, it's really similar to regular tokens. Basically, you have this same structure. Every supply of a non-fungible token, an NFT, is also this list of entries associated with a number of addresses that users control. So now in this case, my address might be in this list, but rather than having a balance on here, it would have an NFT ID or something similar to that. It might be like, well, here are the Bored Apes smart contract that represents that particular set of NFTs. And this particular Bored Ape is represented by ID 34952, and that's associated with my address. Therefore, I own that NFT. And if I want to send that NFT to somebody, then I would tell the contract, hey, please assign a different address to NFT ID 34952. That's basically how NFTs work. Now, you can assign all sorts of other things to this as well. You don't just have to have the ID. You could put in more information associated with those NFTs. Maybe that information associated with the NFT can change over time and it can change its meaning. But you have this idea of I can create this ownership sort of behavior where it feels like, oh, I own this digital thing and I can control who owns it after me. So this is interesting. It's pretty simple in the end. But once again, that was enough to create the NFT craze of 2021, and we're back to these headlines again. That's basically all these things are. The NFTs that you see in the headlines are really just talking about a specific type of NFT where each one of those entries also points to a particular piece of art. And that piece of art might be a Bored Ape that you could use as your Twitter avatar, or it might be something else. It might represent, Nike's been doing some stuff as well, where you can sort of say, hey, I have a digital representation of a pair of sneakers that I own, and it has its own NFT ID, and so I have a digital sense of ownership of that thing. So it's kind of like having a certificate that's created by the artist or the creator of a thing that says, the bearer of this certificate owns this piece of art. It's this certificate. And of course you can transfer that certificate. If you give it to somebody else, then they have the piece of paper that says, well, the original creator of this thing said, whoever holds this piece of paper owns this piece of art. And so now we can have this digital representation of something that now becomes transferable on these open ledgers that people can use. So as a result of this fairly simple thing, we've got lots and lots of these multi-million-dollar NFT projects, and also a lot of NFT platforms that can support this stuff. So we already talked about Ethereum that can do this, obviously, but they weren't the only one. They were just the first. We also have networks like Solana and Binance Smart Chain, and there are even these things called L2s like Polygon, which is that last one. Basically, an L2 is saying, well, we're not going to actually build our own network. We're going to build something as an extra layer on top of an existing network, and maybe it runs a little bit faster, has some special features. So there are all these people that are building platforms that are able for you to run these NFT smart contracts, and then those smart contracts become new things that people can own on the internet. That's basically what NFTs are. But where do we go from here? It's like, the example I've given is, Bored Apes and CryptoPunks and all this kind of stuff. Where does this go from here? Is this just a fad that we've put behind us, or is there something more to it? Well, it's definitely not a fad. Both for tokens and NFTs, there's quite a bit more here. We're just seeing the very beginnings of it. So now let's talk about the future NFTs and, in fact, tokens. Why are tokens and NFTs so important? Well, to predict the future of tokens, we need to understand why they're important. And the reason why they're important is that they can represent lots of different kinds of things. So a regular token, which would be normally called a fungible token, they usually just don't say it. They don't say fungible token, they just say token, is a thing that can represent value or ownership of some kind, and you can hold and trade with others. Again, kind of like we talked about before, but it can represent just about anything. What makes it fungible is the fact that it's totally interchangeable with any other of those tokens, kind of like a pile of nickels. I don't care which nickels I have. I just care the fact that I have 14 nickels that is worth something to me. I can exchange those nickels for a candy bar, something like that. They have some value that's associated with those nickels. And the source of that value can be a million different things, and you can have all sorts of arguments about what is money and why is it worth what it's worth. But basically, a fungible token is just sort of like, I've got a bunch of this stuff, and all of these tokens are all interchangeable with each other, and they're all worth the same thing, basically. Okay. A non-fungible token is a little bit different. As we talked about before, the way we would implement this on Ethereum is by having these entries in our ledger for individual serial numbers or individual IDs. Basically, if we generalize that, we can say that a non-fungible token is just a unique thing that represents value or ownership of some kind. So rather than being totally interchangeable, now each NFT represents something in a very particular way. You can't just swap between them freely. So it's more like, tickets to a basketball game. I might have tickets to seat B2. That's not at all the same thing as the ticket to seat C14. Those things are in different parts of the stadium. They have different value. They have different prices. I might choose to trade them with someone, but you can't say they're interchangeable. They have different meanings, even though there's still a supply of tickets to this particular basketball game. So this is, again, kind of like the Bored Apes. We have a supply of Bored Apes, but each one of those things has different values to different people because they like one ape more than another. And so you can have these unique representations. You can have each one of these things pointing to a piece of art, or really kind of whatever you want. So actually, let's talk about that whatever you want and generalize a little bit, because this is where we get into the real importance of these things. Let's dig a little bit deeper. So some other examples of what you can do here. So for fungible tokens, we can have crypto tokens. We've already talked about that. Don't need to go into it. We can also have something like USD tokens. There are actually today billions of dollars in USD tokens on these open networks, on Ethereum and other networks. And basically what these USD tokens are is they are backed one-to-one by actual dollars in a bank account. There's an issuer of the USD token, and they say, well, right now I've got $1 billion in this bank account, and therefore I'm going to issue 1 billion of these USD tokens onto Ethereum or one of these other networks. And so they say, I'm willing to swap those one-to-one. If you have one of these tokens and you give it to me, I'll give you an actual dollar in exchange in concept. And so the idea here is that now I have this tokenized representation of dollars, and I can exchange those things on the Ethereum network or other networks of this in a much more frictionless way. It's easier for me to do things with that tokenized dollar than it would be necessarily with an actual cash dollar or having to deal with a bank that was holding some dollars in a bank account. It becomes this very sort of low friction, easy thing to deal with. I can start programmatically dealing with those tokens, and I'll get to that a little bit later. Other examples, a little bit less serious. It could represent money in a gaming world. It doesn't have to be all sort of real serious financial stuff. It could be that rather than having, my gold or gems or something like that in a gaming world where I only see it in the game, I could represent it as a token on one of these open ledgers and have that same sort of feeling of real ownership. We could also have tokens represent percentages of shares of a piece of real estate. So maybe there's a piece of real estate and I own 34.6% of that. Well, that might be represented by 36.4% of a particular supply of token that is associated with a piece of real estate. Once again, this is now something that becomes very easily transactable and very powerful. Or it could represent voting shares in a DAO. This is a whole other thing. DAOs are decentralized autonomous organizations. Basically, you can kind of think of it as a club or an organization where there are a bunch of members of that club and they have certain powers. They can vote on things and whatever. So it might be that I have some tokens and that represents how much power I have to vote in that DAO. So lots of different things you can do with tokens. Getting back to NFTs, we have a similar kind of list of things, but different sort of unique applications. So rather than crypto tokens, we might have collectible avatars. Again, this is something that we're very familiar with already. Moving into the financial world, you might have something like lending positions. So this might be that if I want to give someone a loan for some money, I need to represent that loan itself. I need to say, okay, it's kind of an IOU. You issue this NFT that says, this represents the loan for so much money, and in order to repay this loan, you have to pay this back with some amount of interest associated with it. And that lending position itself then becomes transactable. Maybe I sell that debt position to somebody else. This starts getting into all the wonderful abstractions of the financial world. It could also, once we get into gaming, it also could represent unique equipment in a gaming world. It might represent your sword or a particular piece of armor that you won that's been through a certain history in the game, and so it's unique from all other pieces of armor in that game. You could represent that as an NFT and make it transactable inside the game or even outside the game. It could represent a deed to a piece of real estate. So rather than a percentage of share, it might be that, well, my house is represented by this single NFT, and if I sell that NFT to someone else, that means that I have transferred legal ownership of the house to them. Kind of acts like a contract. It could also represent administrator access to a DAO. So rather than voting shares, it might be that there's someone that has like special singular powers in that DAO, and the NFT, it can kind of act like an access badge. They can kind of flash their NFT and kind of like, all right, I'm the admin here. I'm allowed to come in here and do very particular things in the system. These are all notionally really powerful things that you can do with tokens. You can see, and NFTs, you can see how flexible this is. And it creates a new concept. It creates this idea of truly digital personal ownership. It's the idea that owning something, you can own something in just the way that having something in your hand is owned by you, but doing it on an open ledger, doing it in an environment where you can do things much more programmatically. Now, that sounds very abstract, and you might ask, well, why do I care about that? Why do I need to be transacting things on an open ledger? Well, to explain that, I need to take you on a very quick tour of finance to understand why this is so valuable. Traditional finance kind of looks like this. This is a very simplified view, but basically finance, the idea of finance goes back to, roughly speaking, the Renaissance, when we had the rise of banks. And the reason why we had banks that came to be was to be able to do things that just simply cash couldn't do. If I just had a bunch of gold coins, it really limits what I can do with that money. Banks arose to be able to offer different kinds of financial products to people. They say, I want to be able to take out loans with some interest. I want to be able to invest in enterprises. I need to be able to have currency exchange between different types of currency. These are all very difficult things to do on any sort of scale with cash. And so banks came along and said, well, okay, if you're willing to trust your money to the bank, we will then have relationships between our banks. And because we can do that, we can do things that you wouldn't be able to as individuals. We can sort of collect money together, and we can offer lending and settlement and all these sorts of great financial things. That's the basic concept of finance that's been in place since the Renaissance all the way to today. And that same pattern gets used even outside finance. This is basically the model for, Web 2 as we think about it. It's sort of like applications we have on the internet. It's the idea that there are these institutions that are sort of managing the system on behalf of their users. So for example, if you've got an online game that you play, you might think of the fact that you own your equipment in the game, but really you only own it when you're logged into the game. You can't take it out of the game with you. You don't have independent ownership of that thing. So there is this sort of institutional model. So we had to do that with finance. We had to do lots of other things because really that was the only way of providing a lot of these different solutions. But it can cause problems. You can imagine the finance space, if we're trusting all of our money to these banking institutions, well, what happens if there's a bank run? If suddenly everyone wants to get their money out of the bank at the same time? If there's not enough actual dollars in an account, you can create a panic. This is a big deal. It can cause things like the 2008 real estate crash, where it was hard to even tell where all these different real estate investments actually were. They become so abstracted through banks that there was really no transparency in what things were being invested in, what pieces of real estate. These are all problems that happen when we abstract these things into these institutions. But even those problems, it also just defines how the whole system works. Everything is reliant on these institutions, and it limits what you can do. So there's an important new concept, which is something you may have heard of, you may not, which is DeFi, or Decentralized Finance. It's very, very closely related to the concept of Web3 that people have also been talking about recently. The idea of DeFi and Web3 is to remake how these kinds of systems work in a different pattern. The idea here is that rather than trusting institutions to do these things on our behalf, we have more direct control of things. So if we take the finance example, it means that every individual in the system isn't transferring their funds to the bank and then doing things with the bank. They maintain access to their own assets. Now, again, this might start making you think of tokens and NFTs that we talked about, because that's exactly the point. The idea here is we need to do this sort of thing on an open, neutral network. I need to own my assets on a network where I know there's no one that's going to take that control away from me. This is the same pattern that the internet itself took. It was the idea that we could move for communication systems that in the 80s relied on these big companies to make international communication possible. We moved to an internet model where now anybody could build applications on the internet and anybody could connect to the internet on exactly the same basis. We need to do the same thing with ownership, with finance, and with all these other kinds of systems. It's really powerful when you can do that, because it means that now applications can run on these open neutral networks and they can interact with these assets and these identities that we have on digital networks. And so as you imagine, if you think about how revolutionary the internet was for communication, we can get the same sort of things for finance and all these other new kinds of applications. We can remake these kinds of systems in a way where they're much more competitive, they're much more convenient to use, they're much more inclusive, and they're cheaper. And ultimately, they should be just as safe as systems based on centralized institutions. So when people talk about decentralization, this is the thing that they're excited about. It's the fact that we don't need to rely on these companies. We can build a system that's actually just much better this way. It's much more democratic, it's much more open, it's more transparent, it's more efficient. So what does this actually mean in practice? If we have this sort of DeFi system, let's look at a real example about how you would build something on a network like this. And this will bring us back to NFTs. So we can use these, if we can build networks that revolve around the notion of personal digital ownership, we can start to build things that we expect from the real world, but in a more decentralized DeFi sort of way. So let's take the example of a currency exchange, something we're all very familiar with. I can go up to a kiosk, I can give them some US dollars, and I can get some pesos back or something like that. If we want to rebuild this in the other model, basically what we want to do is write some code that can do the same sort of thing. So in the traditional world, a currency exchange is offered by a bank. They have these big reserves of different types of currencies behind the kiosk. I've got a bunch of dollars, I've got a bunch of pesos and euros and pounds and so forth. And so when someone walks up to the window, I can check a current exchange rate. I can put their money into one pot. I can take some money out of the other pot and give it back to them at the right rate. So how do we replicate that on one of these networks? Well, we might do it something like this. We might imagine a piece of code that can accept some tokens from an account and can do a little bit of calculation, can put those tokens into one, a vault of tokens or a pool of tokens, take some other tokens out of a different pool and send those tokens back to the user. And as long as I can write a piece of code to do that, cool, I've now replicated a currency exchange with what should be a really piece of code. You'd expect that this would be really dead easy to build, right? But remember that using the smart contract model we talked about earlier, we have to build everything within that pattern. So this really simple concept that we have for an exchange has to be expressed in terms of something that fits into this Ethereum virtual machine model where I have a bunch of smart contracts running on that network and they can all talk to each other. That's the tool that I have to use, and so I have to use that tool to build that kind of system. And the big problem with DeFi today is that doing that makes the solution actually look more like this. It's really, really complicated. It's stupidly complicated. Something that should be this simple actually means that you have to implement each one of those tokens as an independent smart contract, and then your logic has to talk to those things. It has to check balances. It has to request these balance changes. It has to maintain its own internal cache of balances. It becomes this very complicated, messy thing. And what that means is that the more complexity is, the more work for the developer, the more opportunities for making mistakes, and the more opportunities there were for hackers to exploit this system, to find gaps in that logic to be able to pull tokens out where they weren't supposed to be able to pull tokens out. It's also a way, this example here, by the way, you'll see Uniswap on the slide. Uniswap is the biggest exchange on Ethereum today. And that's why it took the creator of Uniswap something like a year and a half to get from their idea to a production-ready deployment of something that really should have been very simple. It's also the reason why there's literally a website called Rekt that does nothing but catalog hacks and exploits in DeFi today. So DeFi is running on Ethereum and people are doing lots of these financial things here. But literally, like every week, there are hundreds of millions of dollars that get stolen because of hacks and exploits. That is insane. That shouldn't be the case. And so what this means is that even though there's this enormous amount of potential in DeFi, it's really limited. This is why it hasn't taken off. This is why most people haven't even heard of DeFi yet, because you can look at the potential here. The global financial system today is something like $400 trillion. So this blue block represents that box. And that's why if we compare DeFi as it is right now, I just checked this as of October, it's about 0.05 trillion. So it's a tiny, tiny fraction. Its square doesn't even compare. It's less than a pixel on this chart. That's why the problem is, the reason why it's so tiny is because all of this promise that we expected from DeFi, we want it to be competitive and convenient, inclusive, cheap, and safe. It actually isn't. The potential is there, but the implementation of it, the way you have to build and the way you have to interact with these networks is really problematic. So this is why the only NFTs that we see really take off today are things that are really dumb simple, things that are so simple that they don't immediately break right after they're deployed. And basically what that means is Bored Apes and ICO tokens. There's nothing to them. They don't have very much logic. They do really one thing only. And so people found a way to use those things to do something that had a lot of value to people. But it's not where it ends. And so solving this problem, making DeFi really fulfill its promise, is why Radix exists. This is why we're here, and this is why we're talking to you right now. So I want to talk for a moment about what Radix is. Radix is the only decentralized network created to give builders everything they need to obsolete traditional finance. That's the mission statement. Basically, what this means is what we're trying to shoot for is not just sort of build something that in concept is capable of doing these DeFi things. We're trying to build all the technologies that are necessary that allows developers to really take full advantage of the advantages that it should have. You should be able to build applications on this network that have all the same features that financial systems have, or any system that interacts with things of value and identity and all those sorts of things. You should be able to build on these networks, and you should be able to outcompete how the traditional way works because it's so much better. But we need to provide the right tools for that. So over the last 9 years or so, Radix has put an enormous amount of work into building a technology stack that can do that. And there are kind of two major parts to that technology stack. The first part is that we've really focused on building the Radix platform for builders. That means Scrypto and the Radix engine. These are our terms for these technologies. And what I'm going to talk about is as asset-oriented smart contracts. Scrypto is the smart contract language of the Radix network, and Radix engine is our own version of the virtual machine. It's our alternative to the Ethereum virtual machine. Those things are designed specifically to give developers the fastest possible path from idea to production DeFi dApp. A dApp, by the way, is a decentralized app, if that wasn't obvious. The other part of our technology stack is that we've focused on building it for scale, because if you imagine people start building thousands of these really powerful applications that start interacting with tokens and NFTs and doing amazing things, well, that network needs to be able to handle an enormous amount of capacity. It needs to keep up with the world's needs for transacting things. And so our solution to that is something that we call Cerberus. It is a braided cross-shard consensus mechanism. I won't get into what all that means, but basically the result of this is that the Radix network should be able to deliver unlimited dApp throughput, low fees, forever. This is the most important thing. Now, we're on a multi-year roadmap to deliver all this stuff, but we have a design for Cerberus that provides this capability so that as people start building stuff on our network, scale is never going to be an issue. We'll be able to implement Cerberus and we'll be able to scale the network so that anybody can continue to use it without anybody interfering with anybody else. That's the point. So I want to focus a little bit specifically on the Scrypto and Radix engine part because that's really relevant to what we want to talk about in terms of the developer experience. So to describe what the Radix engine is, remember, let's go back to the Ethereum way of doing things. This is how the Ethereum virtual machine works. You have a bunch of these smart contracts. They're running in an environment. They can pass messages between each other. Cool. The Radix engine adds something crucial to the mix here. It adds what we call resources. And resources implement the concept of assets itself. Assets are now built into the platform. Rather than implementing a token or NFT as its own smart contract, now the platform understands what an asset actually is, which makes sense because the entire purpose of these platforms is to interact with assets of various types of tokens, all the different tokens you can imagine, all the different NFTs you can imagine, all these different asset classes. This is why the network exists, and so why should the network speak in terms of those assets rather than forcing people to re-implement those concepts in every single token and NFT? Having that totally changes the whole approach to how you build smart contracts in Radix. So, for example, to make it concrete, as I said, tokens in your account looks very different on these two types of networks. On Ethereum and basically every other smart contract network today, as we saw before, you have a bunch of addresses that have a bunch of entries in these individual token smart contracts. On Radix, tokens are resources that are real things, if you want to think about it that way. Basically, the platform understands the idea of an account. An account is a container that can have these other things called vaults inside it. And those vaults can contain tokens. And those tokens have a certain quantity, and they automatically have certain rules associated with how you can transfer those assets from place to place. They're still very flexible, they're still very programmable, but the core notion of an asset is built into the platform. So you can imagine that the programming experience around interacting with tokens and interacting with accounts and everything else becomes very different. We call it asset-oriented programming. And Scrypto is the programming language we've created to run on the Radix engine to expose all this asset-oriented functionality to developers. What it means in the end is that the Scrypto implementation of Uniswap, that really simple swapping system we talked about, this was the concept that we had in mind. As it turns out, the Scrypto implementation actually really looks like this, and we can show you the code for this. It's basically, you can program a piece of code, and the method input, the method for that trade functionality on that smart contract actually accepts real resources. We didn't have to talk to a token smart contract. The platform understands the idea of taking a resource out of my account and transferring it to that smart contract, along with maybe some request instructions. And then my code can actually speak in terms of putting those tokens into one pool, taking tokens out of a different pool, and then pushing those tokens back to the user that called me. Those are all actual real calls. That's what the real syntax of Scrypto actually looks like. And that is incredibly powerful. And basically, that's NFTs and DeFi on Radix. It means that NFTs can move beyond being these super simple concepts that are a little bit weird and a little bit hard to understand why they're so valuable, and start moving into the world of things that are really valuable for 1,000 different applications. We think that's incredibly powerful, and it's going to revolutionize the way most things in the world work over the coming years. So for developers, we want to invite you into that. We want you to be part of that solution, making use of Radix and building that better world. So thanks very much for listening.